let's multiply. Verify that each line is equal to the same amount. 4 by 13. I think that is, well, 52. Well, because I look at it as 4 10s and 4 3s. 10 plus 3 is 13, so 4, by order of operations, we would have 4 times 13. So we can break this 13 into 10 and 3. And that's actually how I was looking at this problem anyway to do this arithmetic, was this is 4 sets of 10, which is 40. And then 4 sets of 3, or I would be thinking, right, this is 4 added 13 times, so this is 10 times 4 and then 3 times 4. 40 plus 12 is 52. So that means in the middle here, 4 times the quantity 10 plus 3 is equal to 4 10s plus 4 3s. Got it. This is called the distributive property. Yeah? So based on our place value, we can kind of break down some of our numbers and think of it that way. Well, knowing that x represents a number, how would we multiply these two things? Well, we would have to do it in a very similar way that we just did because x is a number. So 4x times plus 4 3 times. 4x times plus 4 3 times. Just like we distributed with the real numbers here. Okay, well now let's do it again, but now we are multiplying by -2. So we're doubling it and we're taking the opposite. Okay, distribute. So -2 sets of 8x's. So 2 sets of 8x's opposite that, and 2 sets of -17 opposite that. So -2 by, so -17 in here. 2 sets of 8x's is 16x's, take the opposite. And 2 sets of -17 is -34, take the opposite. So plus 34. Got it. And remember that x is just playing the role of a number, so this should all work out here. Just like it did here with numbers. Verify that each line is equal to the same amount. Ooh, 9 12s. I don't know, man. Or person. Purple style. Purple? Nah, blue. Okay. Differentiate each problem here. 9 12s or 12 9s, that is worth 108. Ooh, so we would be following the order of operations. Well, 3 plus 6 is 9, and 7 plus 5 is 12. So by order of operations, we would have 9 by 12, which is again 108. Oh, order of operations is much different here. So this would be 3 by 12 plus 6 by 12. Oh, I see. This 9 of them just got split into 3 of them and 6 of them. So 3 of these plus 6 of these. Okay. Well, that's 36 plus 72. Yes, because 30 plus 70 is 100, and so this is definitely 108. Okay. Ooh, and now we have 4 different multiplications here. Okay, I'm gonna write it down here just to have space. I see 21 plus 15 plus 42 plus 30. Let me see. Oh, look, 21 and 15 makes 36. And 42 and 30 makes 72. So it's almost like we broke up these two numbers into separate ones. Oh, 3 sevens, 3 fives, 6 sevens, 6 fives. Nice. Okay, so that means if we have taken some numbers and kind of broken them into pieces, like 3 and 6 makes 9, and 7 and 5 makes 12, then we really have to distribute. If we see 4 numbers separated by operations, we need to have 1, 2, 3, 4 distributions, or here's what I mean, right? This here's the 3 by 7. Okay, let's go green. The 6 and the 5. There's that one. What else needed to be multiplied? The 3 by the 5. It's there. And the combination of the 6 by the 7. So everything in here must be multiplied by the other things. But notice there's no 3 times 6 because they live in the same parentheses. And there's no 7 times 5, again, because they live in the same parentheses. So everything from this set of parentheses needs to be multiplied by everything or distributed into this set. Okay, let's do that. So if we know it works for actual numbers, when we toss in variables, it should work the same because x represents either a number with units, or units. So let's do it. Let's treat it like it's a number because that's a valid assumption. And let's go ahead and compute. So just to keep tabs on this, just like this one, we have x by 3x. We have a 6 by 5. Okay. We have, okay, for this one, I'm going to use blue, whatever. We have a 6 by 3x. And we have an x by 5. Okay, or an x 5 times, however you want to say it, right? So this is 3x, x times, but an x by x, remember, is an x squared. So remember, an x by x is an x squared. So this is 3 x squareds, or x squared 3 times. How much is that? 6 by 5 or 6 5 times is 30. 6 sets of 3 x's makes 18 x's. And x 5 times is 5x. So plus 5 additional x's. And just to write this in descending order in general form, 18 x's plus 5 x's, these are like terms with like, so they're not squares and they're not non-x's, they're kind of linear. 23 of them total. 18 x's plus 5 x's makes 23 x's. Got it. Let's do it again. Okay, we could do this. Same pattern. So negative 4x by 2x plus 7 by 9. Okay, I'm going to go a little bit faster now. Plus 7 sets of 2x's. And plus, oopsie, negative. So it could be plus a negative, however you want to write it, minus 4x by 9. Okay. So we definitely have an x by x. So we have an x squared here, but we have negative 8 of them because we have 4 sets of 2 and opposite that. So we have negative 8x squareds plus 63 plus 14x's minus 9 sets of negative 4x's is minus 36x's. In descending order and combining this, 14 take away 36. Gross. That's debt or below. Negative 22 x's altogether, plus 63. And let's do it again, but now, we're extending it. So making sure everything in this first set of parentheses gets distributed by, or into everything in the second set of parentheses. Here we go. Let's do this. So we have an x squared by a 5x. So by the way, we would have an x squared by another dimension of x. Yeah? So here's an x squared by x is an x cubed. Let's see, what else do we need? You know, I'm going to use, up here I used red to trace that negative 4x. I'll use red again here. I'm going to go like that. So an x squared by a negative 8. So negative 8x squared. And what's next? We have negative 4x's by 5x's, so minus 4x by 5x. That will involve an x squared in it. And we also have this negative 4x needs to be multiplied by this negative 8. So negative 4x's by negative 8. Careful with your signs. But we also have to distribute this 9. So we just distributed all of these, but also the 9. So plus 9 by 5x. And then plus 9 by negative 8. Okay. Wow. So we have 1, 2, 3, 4, 5, 6 multiplications here. There were 3 terms in the first set of parentheses, 2 terms in the second set, and so 6 multiplications altogether. This is 5x cubes. X squared by x makes a cube. And minus 8x squareds. And x by x is an x squared, so minus 20x squareds. Negative 4 by negative 8 is positive 32, opposite of a negative there. And plus 45x's and minus 72. Got it. Woo, multiplication. Distribute, distribute, distribute. Okay, couple of remarks before we dig into a real scenario, yeah? First, remember that 3x's plus 2x's makes 5x's. Hold on, I'm going to write this down. Remember that 2x's plus 3x's is equivalent to 5x's, since this is 2x's, so multiplication is repeated addition, remember. So this is really x plus 3 more of them. 1, 2, 3. So this is 1, 2, 3, 4, 5 x's added together. Right? But, so there's a but to this sentence. X squared by x cubed is x to the 5th, since This represents repeated multiplication. So here's x squared times x cubed to give us 1, 2, 3, 4, 5. X multiplied times itself 5 times. So I just want you to be careful. When you see a 2x, it doesn't mean x squared. Those are very different. This represents repeated addition because it's x plus x, and this x squared represents repeated multiplication. It's an x times x. Okay, so this seems to be a very common thing that always hangs many people up. Another thing that I would like to remark upon is this acronym FOIL. So a lot of people say, I'm going to FOIL now. And that's an acronym to help make sure that you include all of the pieces. But I find it more helpful to draw those arcs and make sure that every piece from one set of parentheses matches with another, with each thing in the second set of parentheses. So FOIL is an oopsie, forgot the R in acronym. Okay, an acronym that helps ensure all multiplications are done. Uh-oh. All multiplications are remembered. It's a reminder, right? Do the firsts, do the outers, do the insides, do the lasts. Don't forget any of them. But I prefer the arcs myself. Now that doesn't mean you have to do it, but I prefer using arcs to keep tabs. And that's only because it's extendable. So what I mean by that is firsts, outers, inners, lasts works if there are 2 terms in the first set and 2 terms in the second set of parentheses. However, that doesn't really apply if there are any more or less sets of terms. I mean, the firsts, the outers, the inners, and the lasts would leave out several of the multiplications we needed in number 7. So I really do prefer the arcs to keep track to make sure nothing gets left out, but nonetheless, this is very popular. Okay, in the next video, we will look at this real data example. So we're going to need, before I actually start this video, I'm going to put this into, so just so you know, so that you can maybe do this. I'm going to put this into list 1 because it's the explanatory variable. I'm going to put this into list 2 as a responding variable, and I'm going to put this into list 3 as a different responding variable. So I'm actually claiming that the time is explaining the value and the number of acres, and that it's independent of the value and the millions of acres of farmland.